My name is Richard Covey, and I'm a professor in the Department of Forestry. I'm actually a forest ecologist, but I've gotten very interested in this building and mass timber construction for reasons that I think will become apparent later, some of the connections between particularly the carbon cycle and construction. So this is an exciting project for me. And not just for me, but for MSU and for the Department of Forestry and some affiliated departments that have been working on this. And really from the outset of this, the Department of Forestry and several faculty here, David Dio, George Berghorn, Mochan, Pascal, have been involved in providing tactical expertise to the operations side of the university, and finally kind of swayed the university to make the choice to go with a mass timber building instead of a conventional steel and concrete building. So I'm going to give just a quick overview of the building so you know what I'm talking about, then I'll get into an outline and more detail in several components. So it's a $100 million project. It's about $80 million that's going towards the actual construction. It consists of a renovation of the old Shaw Lane power plant and then two mass timber additions. One that's 80,000 square feet and on the south side, and then 40,000 square feet on the north side. And so all of the teaching labs at MSU for the introductory science courses, chemistry, physics, computer science, are going to be taught out of this building. And the renovated power plant is going to have some more community space, so there's going to be a Starbucks or equivalent, food service, more meeting room type space. So a lot of people will be moving through this building. All right, so but I wanted to start off with, first, what is mass timber? I don't know if everyone knows that. Why it's important. Why is this particular building at MSU significant? Then I'll give an overview of the STEM facility. I've been on at least a dozen tours over there now with various groups, and I haven't participate in all of the tours. This is generating a lot of interest, but it's given me the opportunity to interact with the construction manager and others. And so I think it's interesting to see it from the constructor's perspective as well, and whether this is technology that's going to take hold. And then I want to wrap up by talking about ways that we're planning to magnify the impact of this building, both with respect to moving the construction industry and providing education, but also in terms of the opportunities that this provides for the Department of Forestry and affiliated departments and MSU generally. All right, and I want you to, as I'm going through this, I want you to be thinking about that as well. If you see connections that we could be making that, and it's largely a forestry crowd here, so that would be of benefit, that would be something that I'd be interested in knowing about. All right, so what is mass timber? It's used in two different ways. Sometimes it's meant as the construction method. So it's actually, when it's referred to in that way, it's a framing style of large buildings where the load-bearing structure is constructed out of engineered wood. So that's one way that mass timber is used. The other is to talk about the particular pieces of engineered wood, a category of engineered wood, mass timber, large, massive pieces of wood. What we see here is a relatively new product that was developed about 20 years ago in Europe. It's called cross-laminated timber. You can think of it as like plywood on steroids. It's like these big panels that are really strong. Each layer is made out of 2x4s or 2x6s, and they're glued together, it enables you to have some really large, long spans. So it's fairly lightweight and strong. So you can see, if you look at the top of that, you can see the crossing 2x material there in that panel. Another type of mass timber element is what's called Glulam. And Glulam has been around for a long time. And Glulam is basically when you have boards that are glued together in parallel. And so there's not any kind of crossing of grain there. But it's used extensively for beams, as we see here. It also can be used for columns. So instead of this concrete column, we could have a Glulam member there supporting that building. And then on this particular photo, there's actually another type of mass timber product. This is called nail laminated timber, where you basically have 2x4 stacked on end, and you nail through them to create a large panel, right? So the 2x4 standing up. Now that's been used to some extent, but the problem with it is that if you don't know where your metal is, if you're trying to put a penetration through a panel like that. So it's seen probably more limited use. All right, so why is mass timber important? Well, this is some of the link back to my interest in ecology. 39% of CO2 emissions come from really buildings and construction. So if we divide that up, 28% of that is coming from the operations of buildings, so heating, cooling, and lighting. But 11% of that is coming from the building itself, and that's mostly from the production of concrete and manufacturing of steel. So that's pretty substantial. And if we can shift this to a more sustainable material that actually stores carbon out of the atmosphere, and if the building method also allows us to construct tighter buildings that are more energy efficient, we can move the needle on this in this aspect of carbon emissions. And this is especially important, and so I have to say that I was totally shocked by this when I came across this. But projections by the United Nations Environment Program is that over the next 40 years, we're going to have 2.5 trillion square feet of new buildings constructed globally. So that's the equivalent of adding the square footage or square meters of Paris every week for the next 40 years. And if you look at these projections, divided by region, you see in Africa, that's this top line here. So this is current square footage, what existing buildings, and then these are buildings that are planned over different decade time periods. So in Africa, the square footage is going to more than double. About doubling in China, more than doubling in India, close to doubling in North America, and so on. So we're going to see more building in the next 40 years than more new building than the existing space that we have. So if we want to make a difference with respect to mitigating greenhouse gases, we should be thinking about other ways of constructing buildings and the types of buildings that we construct, especially with respect to their energy efficiency. Okay, so some other reasons why mass timber is important. It provides an important market for wood, and oftentimes we won't see management for conservation or for wildlife and other purposes, unless there's some market there that gets the landowner to manage their forest. These are photos. This is ponderosa pine in northern Arizona, and another aspect of this is just the reduction of fire hazards and the natural, with small surface fires, the stand structure looks much more like this, with larger, more evenly spaced trees. With fire suppression, it looks much more like this, and those forests are much more prone to catastrophic wildfires now of large magnitude, and restoring those forests into more of this type of structure is expensive unless you have markets for that kind of wood. Mass timber, and if this takes off in the construction arena, could provide that type of market. Okay, and then also supporting rural livelihoods and economies, I think is important. Okay, so that's a little bit of broad background. So why is this MSU building significant? Well, there are three major reasons for that. The first is geography. So this is the first contemporary mass timber building in Michigan and in all the states surrounding Michigan. So Ohio, Indiana, we could probably count Illinois, and Wisconsin. Now, when I say contemporary mass timber building, I'm talking about a building that's incorporating both this new product, the cross-laminated timber, as well as using Glulam columns and beams extensively. So we have examples of other places in the Great Lakes region that have used elements of mass timber. So, for example, McDonald's flagship franchise here in Chicago. I don't know if anyone has seen this. I've not yet seen this in person, but this is the building under construction, and you can see that they're using largely steel posts. There's a small part of the interior of the building that's using cross-laminated timber. This building has gotten a lot of press for using a relatively small amount of wood, but it's because it's using the CLT. But you can see here, the cross-laminated timber is in this interior part right there on the ceiling, right? And then pretty much everything else is steel columns. And the building does have photovoltaics on the roof, which is a nice touch. And then for a long time, I'm not sure when it was constructed, but the Superior Dome at northern Michigan in Marquette uses these large Glulam beams to support that dome structure, and filled in here with wood to provide the deck. And it is, you could consider it it's definitely a timber building, but it's not incorporating cross-laminated timber. So that's what makes the MSU building significant, is it's really the first of its kind in Michigan and surrounding states. Another reason why it's significant is because of the use of the building. As I said before, all of the introductory science labs are going to be taught out of this building. And when we look at other mass timber projects that have occurred in the US, most of them have been focused on residential, like student dorms, office buildings. Very few of them, or none of them that I can think of, have had more of a working building where you have wet labs, something that would be more analogous to a hospital. So this opens up it's a new frontier, a new dimension for mass timber application. And so I'll get into more detail on this later, but here's an example of one of the wet labs, a schematic that will be in the MSU building. You can see the CLT panels there on the ceiling, and then this is an analogous space in the building now that's under construction. Okay, and then the third reason why this is significant or distinct from other projects is because it incorporates a renovation where mass timber is going to be used in the renovation. So you can see here, this is the old power plant, and then on that above those the I-beams there, the steel I-beams, are CLT panels for the floor. So where they were able to incorporate CLT and mass timber in the renovation, they're proceeding with that. So that's also a novel application. Okay, so then overview of the MSU STEM facility. It's located in a fairly prominent spot on campus, just on the southeast corner of Spartan Stadium. And this is when I was exiting the stadium earlier this fall. There's the Jumbotron on the south side, and you really got a nice view of the building going up. So it's a great opportunity for exposure. Another shot from the street. You can see Spartan Stadium in the background. Okay, so here's the basic site plan. The existing power plant that I think was operational until sometime in the 1960s and hasn't been used much since. So before any of the timber was in place, they put in the concrete foundation, and I wanted to point out a particular element here. So you see this black metal connector. So that is connected to a fairly deep concrete foundation. It actually went all the way down to bedrock, and they overbuilt this building. They're being a little conservative since it's the first time this technology is being used in this area. But this went all the way down to bedrock, and then this is the connector where the mass timber columns will rest. So when they started out, there were a bunch of these all across the site. Okay, and then, so wood columns are going to be, have gone up. This is a little misleading because it's not just one continuous column, but it's a column for each floor. And then the wood Glulam beams. So this is the original architectural schematic for the connections. So you have a Glulam column coming up, a steel connector, and this steel connector has changed. And then the Glulam beams coming into that connector, a layer of CLT on top of that, and then on top of the CLT is a soundproofing barrier, and then a 3-inch cap of concrete right on top of that, which provides greater soundproofing as well as a more durable floor surface. And then your next floor would be connecting here with the steel connector and the similar kind of pattern building up. So the connector is similar to that, but it changed a little. I don't know how well you can see this, but so you have the steel plate coming up. It is embedded in the column below, so you can kind of see the outline of this column that is what looks like being T-shaped, and it looks T-shaped because it is notched to receive beams. And then, so you have this plate with all these holes drilled in it, and then a column goes on top of that, and these stainless steel rods are driven in to that to secure it in place. All of this is manufactured off-site to very tight tolerances. So when they bring the materials onto campus, they're really just assembling, it's like a big erector set, but everything has to go into its place. The tolerances on this, on these long members, are 1 millimeter. So if you don't have everything lined up, if manufactured to within 1 millimeter, your stainless steel rods are not going to line up between your steel connectors and your wood columns. Okay, and then so here's some of the first beams, Glulam beams going into place. So everything has to be staged pretty carefully. You can see notches here in these columns where the beams will rest, as well as hangers for other ones. Yes, Dan?
The notches, were they made at the factory offsite, or were they cut here?
Offsite. Pretty much everything was.
Even the Glulam or the CLT floor penetrations, were they cut?
Yeah, and there were very few floor penetrations, actually. You'll see some other photos later that show that. Okay, so here's one of those steel connectors. So this is embedded right into this column, and then it has those holes in it again, so that when the Glulam beam comes out, they'll drive those stainless steel rods in just to secure it in place. They're not holding any weight, it's really the connectors and the wood structure that's bearing a lot of the weight. The stainless steel rods are mostly just to fix things in place. So another example there, this is one of the stairwells that was made out of 7 layers of CLT in order to meet code for burn-through times. Okay, so back to the architectural schematic, building up here. So we have you saw the columns going up and how those were connected. CLT decking then on each floor. So you can see that going up, the CLT is here. Up on the 3rd floor, the CLT hasn't been placed yet. And then that concrete cap right on top of, well, the CLT, but with that soundproof barrier in between. And then the floors are going to be polished concrete. So, and I'll return to this point, but the builders really like this because so much of what they're doing, they're putting finished product into place. They're pouring the concrete, they're polishing it, that's their finished floor. All of the mass timber already has a protective coating on it. I think it's polyurethane. They don't have to do any finish work on the wood. It goes into place and it's done. And I'll get to that towards the end of the presentation. All right, so you can, I just took this photo last week. You can begin to see the building envelope coming on the south side edition. And the building envelope, so the kind of the exterior walls, right, what envelops the building is completely separate from the mass timber framing. And that allows the construction of a very tight and energy efficient building. So this is being built to a LEED, at least silver standard. And it's not because of the mass timber, but it's more because of the energy efficiency aspects of the building. So this is steel that will take the envelope building materials, which is glass and brick. Okay, so there's a webcam with the time lapse on this building. I'll go through it, and you can see the south side being built first. So this would be mid-June, and then they didn't get the webcam set up right away, but they started off slow. This was probably like a week or 2 of work until they were learning how to do the construction. But one thing to notice is how this speeds up over time and how much more efficient they are in the assembly. Okay, you can see the stairwell going up. All right, so now things are taking off and those beams are in place pretty quickly. You see the CLT in place. Now they're shifting to the north side. This occurred towards the end of summer. You'll see our recent snowfall in here that we had, was like a couple weeks ago. There's the snowfall, that's gone, and there we are till a few days ago. All right, so it's a very fast method once you have the expertise in place, because so much of it, almost everything, is done off-site, and it's really just an assembly process when you get to the construction site. All right, so that's what the finished building looks like on the exterior. This is on the west-facing side of the building, south and west-facing. So it looks very much like other buildings on MSU's campus, right? You wouldn't know that there was anything special about this building from the outside. It's brick and it's glass, and that's actually a real advantage to this building, or the mass timber construction method, because it's very adaptable. You're not building like an up north woodsy national park kind of cabin by using this method. You can put any envelope on the building that you want and have it fit in with the rest of your architecture. Okay, and then this would be on the east side of the building, which I think is, the various kinds of shapes and textures here make it an interesting looking building on the east facing side as well. All right, so here's the floor plan. I'm not going to focus a lot on the floor plan per se, but I just wanted to orient you. This is the south addition here, and I'm going to be bringing you into this atrium and showing you around the interior. The north addition is up here, so the north side are dry labs. That's going to be more physics and computer science. It's the wet labs that are in the south addition here. Okay, so this is going into that atrium area, and if you were to go in this direction, you'd be entering the old power plant, and all of the Glulam columns and beams are being left exposed. And as I said before, they already have a finish on them. I'm just doing a pan around that atrium. So we're looking down a hallway now, and another thing that's really nice about this building is that they designed it so there's a lot of common space and a lot of places for students to congregate. And one of the issues with the introductory labs is that students might have to do some calculations or do work in a group, and if they're in the lab, they can't take their goggles off if they're in a wet lab, right? So they were very deliberate about designing these spaces outside of the wet labs so that students could take their goggles off and work on calculations together. So you'll see a lot of that in these interior schematics. Okay, I'm still panning around that atrium. You can see the CLT panels there pretty clearly. And that's going up to the second floor. Right, that's what it looks like now. And it's a little wet, but it's, for the most part, they'll take off these OSB protectors that are on there temporarily, and your atrium is largely finished. If you look at this versus that, the same elements are there. Okay, and then I had mentioned the common space already. This is showing one of the corridors, exterior corridors, that provides that kind of gathering space for students. All right, one of the wet labs. The wet labs were designed to be very flexible. So we have these utility drops that have compressed air, natural gas, electric, internet, all the things that you would expect in a wet lab. And they can move on a 20-foot radius. So an instructor can ask for one of these teaching labs to be reconfigured at the start of the semester. It would take about 2 days to do a reconfiguration. So it's no more of the heavy resin lab cabinetry. These are, the lab tables can be moved around, the utilities can be moved around, and creating a lot of flexibility for the instructors. Because this is the wet lab side, there are more utilities here, and all the utilities are coming down from the ceiling. You can still see the CLT peeking through up above the utilities. And then, so now we're moving to a schematic for the dry labs. There's not as much utility infrastructure there. You get a clearer view of the CLT and the Glulam beams on the dry lab side of the building. This is probably a physics lab. Okay, I already showed this, this diagram of the CLT being incorporated into the renovation of the power plant. One of the boilers is going to be kept there as part of an art project. And they're actually going to be like video projections within the boiler. An artist was commissioned to do that. Here's the boiler now, so we have a little bit of work to do. And then just going up the floor of the old power plant, you can see the incorporation of the CLT, lots of gathering spaces again for students. So that's a kind of a tour of the building. So this building is going to consume a lot of wood. So for this building, 1.3 million board feet. The ratio is for each square foot of building space, it's about 11 board feet of lumber that's going into this building. And now that consumes a lot of wood. It's FSC certified. It's coming out of Canada, out of Quebec. Nordic Structures is the supplier, and it's mostly black spruce. So they're working with fairly small diameter trees, like 6 to 8 inch diameter trees that they're making all this material out of and gluing it together. So because it's a lot of wood, it's also a lot of carbon. I'll get to that in a minute, but I just wanted to point this out too. If we look at swaying some of the non-residential construction to mass timber in the upper Midwest, which is on the x-axis here, and the additional demand of wood that would result, if about 5% of non-residential construction switched over to using mass timber, it would be an additional 122 million board feet of lumber demand per year. That's only 5%. I mean, we could see much greater increases than that potentially, but it also suggests that this would provide opportunities for forestry and for management and to grow the wood sustainably. All right, so now let's look at carbon. So the building will store the equivalent of 1,856 metric tons of CO2. That's equivalent to about 4.5 million vehicle miles, 222 homes energy use for a year, and that's not taking into account the avoided emissions. That's just the carbon that is embodied in the structure, right? Because you're also, the manufacturing of these wood structural elements is much less energy intensive than the manufacturing of concrete and steel. And that's probably the biggest part of the story, is the avoided emissions, or that 11% figure that I showed you early on. So Lauren Cooper provided this diagram for me, and I really like it, where we normally think about the forest carbon cycle as including vegetation, interactions with the atmosphere, and vegetation dies, and some goes back into the soil, some decomposes and goes back into the atmosphere. But I think that this is an opportunity to also, for forestry to integrate across ecology and wood products, and to think about the residence time of carbon in wood products. And also potentially, and what's not shown in this diagram, is the potential recycling of wood products to increase that residence time out of the atmosphere and tied up in a long-term structure. And of course, another possibility would be after a wood product has had its useful life in, say, in a building, it also could be converted into energy so that you capture yet another benefit from it before that carbon goes back into the atmosphere. Okay, some perspective from the construction manager. So one thing that I've heard him say is that it's important to work with experienced partners on this. There's no expertise in Michigan in mass timber other than what the contractor here has developed. This is all new for the architectural firms and the builders. So I guess one of the major things to take into consideration is that it requires a lot more planning than a standard steel frame and concrete building. So the construction manager has often said it's important to design early. You want to know exactly where your utilities are going to be placed. You want to avoid, because the wood frame is the holding, is the structural element, you want to avoid penetrations through those Glulam beams. You want to avoid penetrations through the CLT wherever possible. So you don't want to be cutting holes in it, and everything has to be planned out ahead of time. Okay, and that's a shot on the edge of the atrium again. You can just see the complex of utilities that are going in. And each of the utilities, they have these hangers here. You can kind of see this hanger coming off of one of the Glulam beams. And all of these are essentially surveyed in. They have marks on the floor for where each hanger is going to go. So that's the extent of the planning. There's very little flexibility or changes once you're on site. Okay, flow and sequence become really important. Every piece has its place in the building. So these aren't stock items. You can't just call someone up and say, I want a Glulam column, or I want a CLT panel of such and such dimension with these penetrations. You're going to be waiting a couple months for that. If you're working with steel I-beams, you can call the steel supplier and probably get it the next day, and they would modify it on site. So everything really has to be planned out again. And it's because there's very little of the on-site modification of the materials. And then the third thing that the construction manager has said is that you have to take into consideration the material handling, because this is a finished product, so you want to protect it. They ended up, I don't know if they had planned this originally, but they ended up putting these OSB protectors around each column to avoid damage from the other construction. Moisture content is also a consideration. They're fabricated to 12% moisture, and they try to stay below 16 to 18% moisture content. So if you have a heavy rain, the wood's going to absorb some of the moisture. If they get up above 18%, they have to cease construction and wait for the wood to dry out so that everything is still in alignment. I don't that they've had this problem, and they've been protecting the wood, but it is a consideration that you have to take into account. So those are more on the cautionary side of things. And there are other things that the construction manager has said that I also think are important and can be viewed as benefits. The aesthetics of it. You know, if you look at a wood column in comparison to a steel I-beam, there is an element there of people being attracted to these natural features, right? It might go deeply into something related to biophilia. On cost. So when MSU, and this is going to be really important for businesses and whether they adopt this construction method or not, right? A lot of things in the business world really come down to it, not necessarily sustainability, but it will come down to whether costs are competitive. So when MSU started into this, they did a comprehensive cost-benefit analysis. How much would it cost to build a conventional steel frame structure? How much would it cost to go with mass timber? And it came out to be about the same, which was a pleasant surprise. But after, in talking with one of the people who gives the tours, said recently, if they were to build this building again, with the experience that they've gained, if they had the same crew, they think the same crew could build it 3 to 5 months faster than what they did the first time around, because there's just a learning curve with it. And that would translate to about a 10 to 15% cost savings. So if you have a new method that of construction that has a cost savings with it, has sustainability characteristics associated with it, it's more likely that it's going to take off. Now, in the longer term, it's also possible that those costs would come down further because the state of Michigan is very interested in attracting a manufacturer to the state, and then that would lower the transportation costs because it's a 2-day truck drive from northern Quebec to Michigan, which isn't great for our carbon accounting, but you have to get, you know, a showcase. You have to get something started as an example if you want to provide an educational piece for the construction industry. All right, so another aspect of this is that you're able to have a compressed construction schedule. The building can go up much more quickly, and the reason for that comes back to these tight tolerances. So you're erecting this building with these wood members, everything's in place. When you construct a steel frame building, and I didn't realize this until talking with the construction folks, is that when you construct a steel frame building, at the very end, you put your entire structure up. At the very end, you have winches and chains, and you have to square the building up. And you have to square the building up before you put in any of the utilities. So you can see here, in this photo, they're already putting up studs on the first floor and plumbing before they've finished the third floor. So they can finish the structural elements of a floor, move in with the trades on plumbing, electrical, drywall, and really compress the construction schedule. So they see this as another major advantage. And that's because they don't have to do the squaring with this, right? You wouldn't want to have a pipe in a building if you're going to have to square up because that pipe might burst or torque under pressure. So it's a real advantage to have a building that's square as you're going up because it enables you to install the utilities earlier. It's also a time saver, the minimal finish work that like I already talked about. And kind of surprisingly, and maybe counterintuitively to a lot of people, there's not the need for fireproofing. And I'll get to that in the next slide. But first, wanted to make the point that there's also, in a heavily urban environment, because there's less on-site work, there's lower truck traffic, so fewer materials are coming in, there's less noise and less waste is generated at the actual site. So there's very little waste removal, lower need for trucking at the construction site. Okay, so this is a somewhat famous photo of a factory fire in New York State. This is a Glulam column, or Glulam beam, that was part of the structure. And the building reached temperatures such that the Glulam column charred, it burned. It still had the structural integrity though because it didn't burn all the way through. But the building reached a temperature such that the steel I-beams basically gave up their structural integrity and then folded over that Glulam column. So any modern building that uses the steel frame construction, and you've probably seen this, has to have this fire retardant, fireproofing sprayed on the steel members. And the wood doesn't require that because the wood would char on the outside. It gives you plenty of time to evacuate the building from a code and safety perspective. But with steel, if it reaches a certain temperature, you could have this kind of catastrophic failure, which necessitates the fireproofing. So the construction folks appreciated the fact that they didn't have to do all this spraying of the framework at the end. Okay, so just a few things then on magnifying the impact of the building. We have plans for doing outreach. We are going to be hiring an outreach specialist for this building and really focused on that person doing tours and serving as a resource for developers, as well as architecture, engineering, and construction, reaching both the industry as well as university students. You talk to architects, they're not familiar with these methods. It's the same with the construction folks and developers. So having a bridge there and being able to use the building in education would be really important. That person should have expertise for substituting wood throughout the entire building process. There are all kinds of complications that come in, like code compliance and sourcing, specifications that have to be taken into account, and then other communications that we're doing. The location of the building is great for doing outreach and pop-up outreach about sustainable building construction and sustainable forestry. We have secured funding from a few different organizations. The Michigan DNR, Department of Ag and Rural Development have contributed funds towards the outreach as well as extension, and then forestry and the School of Planning, Design, and Construction. We are working with industry as well to get some financial support and get them engaged in this. So beyond the impact, potential impact on the construction industry broadly, I think that this is also an important opportunity to magnify the impact for MSU. And one example of that is that I think that forestry has worked together more closely now with the School of Planning, Design, and Construction than previously. And that's unusual and puts us at a really nice advantage in comparison to other universities that we have that good collaboration going. It's helped, there's a lot of interest generated by the building. It's helped in terms of relationships with industry. The state of Michigan is very excited about this, and especially from an economic development perspective in attracting a manufacturer to the state. MSU Extension has a large unit that's focused on community development, and they're excited about this, and we've had conversations, and that's the main reason why MSU Extension wants to invest in this. There are opportunities for research. George Burkhorn recently received a grant. You can think about our teaching opportunities, wood science and other courses, and a clear tie-in with the forest carbon and climate program as well. So I think that, just to sum up, this is a significant building, and that could be part of the solution to mitigating climate change. It also provides important opportunities to collaborate on a number of things. Research, teaching, outreach, and I really, if not today, then later, would love to hear your feedback on other ways that we could use the outreach that we're planning and this building to really enhance those collaborations and to support both sustainable construction and sustainable forestry. All right, so I'd be happy to take any questions. Yes?
What would be the lifespan of a building constructed with this type of wood as opposed to a more traditional building?
So MSU builds buildings to a standard of at least 100 years. And there are structures in Asia, wood structures that in Japan that are several hundred years old. So if you protect the wood, I mean, if you have a termite problem, then you're going to have to get on it. But if you protect the wood, it can have a very long lifespan.
Would the coatings on the wood, or I'm assuming they would also help protect against termite damage, or maybe?
I don't know about that for sure.
Okay.
It would. We have some coatings people in the room who might be able to comment on that. Saeed, do you?
Yeah.
Yes.
I know it's a relatively new technology, but do you know if anyone has used or been experimenting with different species for construction?
Yeah. So in North America, it's largely been conifers that have been used. In Europe, they started with softwoods, but they are experimenting with hardwoods. And one of the considerations that the Michigan Economic Development Corporation and others at the state in attracting a manufacturer, they're very interested in a European manufacturer and setting up shop here because we have more hardwoods than softwoods. But incorporating both, there's definitely the potential to incorporate hardwoods. Aki.
It seems like the construction company had very specialized technique to building, and am I true? It looks like they have to plan way in advance compared to the conventional building.
That's true. The planning is definitely part of it, but I think that's the supplier has become really important. So this company from Quebec, Nordic Structures, has experience with this, and they have, I think, helped enormously with Granger Construction, who's the general contractor on this project. And they provided that expertise with the planning and helped out.
Does the US have that's kind of like suppliers?
Not yet. I mean, there are a couple of manufacturers in the Northwest, D.R. Johnson in Washington State, Smartland in Idaho. There are a couple places under construction in Maine and then in Alabama. But there's not a manufacturer in the Great Lakes area.
Is there a reason that we went with a Canadian company instead of one of the American ones? The difference in construction?
Yes, it was bid out as mass timber, and they came in with the lowest bid given the quality of product that they could deliver. So it was competitively bid.
Okay.
Yeah. Lauren.
To the extent of, I mean, you mentioned this briefly, but other groups and organizations that are kind of watching this and what the influence might be in other types of construction decision making? I know like U of M was interested in some of this, but could you just elaborate on that
Yeah.
more?
So there are definitely other universities that are interested in this. So Michigan Tech is exploring the possibility of putting up a new building with mass timber now for their Allied Health Sciences building. And it's interesting, so some of the momentum in working with the operations side of the university was helped by Michigan Tech, especially through the Michigan Forest Biomaterials Institute, which they invested in and they were a major partner in that. We've been part of that too, but the Biomaterials Institute was important in putting on some mass timber workshops that we got folks from our physical plant to attend. And now we've developed the expertise at Michigan State to do this, and our physical plant's excited about it, and they're now helping Michigan Tech with the specs on their building. We also had a group from University of Michigan come up. They've been interested in a mass timber building for a while. Nature Conservancy is another organization that has really strong interest in this. And one point that I didn't make previously, but I think that the Nature Conservancy's view is that it's important to have markets for wood, to create the wealth, to do conservation. But the other point of it is that without mitigating climate change, a lot of our conservation efforts are going to be for naught. So we really need to be moving forward on sustainable economies, including construction methods. So those are some of the organizations that have been interested. Some of the tours that we've done, the very first tour was a person from Simpson Strong Tie Company. I don't know if you've ever built a deck with joist hangers. Simpson builds those metal connectors, and it was an engineer who was interested in seeing how the wood members were going to be connected together. That's where I got those initial photos of the foundation with the steel bases. So there's been, it's from a wide range of sectors that have shown interest in it. Randy.
Rich, can you back up about 5 slides to the construction manager's view? I think it was the first one. What? No. Go back.
Okay, this was the very first one.
Yeah, okay, keep going back. Not stop you. Well, why don't you stop right there?
Okay.
This is probably only of interest to me as a tree nursery person, but where that brick building is on the right top there is the site where our department had our very first tree nursery in around 1905. So 110 years ago, we were growing millions of tree seedlings to help reforest Michigan.
Right.
And now 100 years later, it's come full circle. You're putting this building up right next to it.
That's a nice story.
It's kind of cool.
Although it's too bad that we got the wood from Quebec. But it still works.
Yeah.
So is it right at this building?
Yeah, that's a Central Services building.
Central Services,
I have a
yeah.
picture from the early 1900s.
Yeah.
Almost that same view, and you can see the nursery there.
Well, we should let Lauren Noel know about it.
Yeah. So, it's just cool.
All right, so without further questions, it's 4:30, right on time. Thanks, everyone.